Hello, my name is Brian Motil, and I'm the principal investigator for the packed bed reactor experiment, or PBRE.
And I'm Cathy Frey. I'm in charge of developing the operations products for PBRE.
The goal of the PBRE is to conduct a fundamental study of gas-liquid flows through porous media for the first time ever on the ISS. Flow through porous materials are encountered in many places in everyday life, both in technologies such as chemical reactors and nature such as water, gas, and oil flow underground. In space, specific applications include chemical reactors for air and water revitalization, as well as flows to deliver water and nutrients to plant systems. Here are just some of the many current and future applications for this technology. These systems operate very differently when in the microgravity environment, especially at low to moderate flow rates, because the draining effect of gravity no longer influences the flow distribution and pressure drop. Instead, the effects of the interfacial or capillary forces along with the viscous forces control the flow dynamics. The PBRE is designed to develop a basic understanding of this important class of flows in the microgravity environment for future space exploration. Here is an example of how these other forces affect the flow. At the very low gas flow rate, the steady conditions are called bubble flow. As you can see, gas bubbles flow around the fixed packing, frequently getting momentarily trapped in a pore until another bubble comes and merges to make the bubble large enough to get swept downstream. As the gas flow is increased, this effect broadens across the column until an organized alternating pressure, or pulse flow, can be measured as gas-rich and liquid-rich phases pass through the bed at velocities much higher than the bulk flow rate would indicate. This is not just a curious hydrodynamic behavior, it has important consequences on the operating conditions and parameters for chemical reactors. In fact, it is possible to operate a chemical reactor of this type in microgravity at much higher efficiencies than in normal gravity if the design and operating parameters are properly selected.
The space station experiment will provide a wide range of water and air flows through two randomly packed test beds. The packing will be 3 mm spherical beads, which are poured into the bed and then held in place by spring-loaded end caps. This is what the experiment looks like with the test column in the foreground. The key diagnostics will include very sensitive pressure and temperature measurements at points along the column, as well as 2 high-speed and high-resolution video cameras to determine the flow conditions.
After the initial testing is complete, the PBRE will be available for additional research. The test section and diagnostics are replaceable to allow for any type of air-water experiment within the envelope of 24 inches long by 5 inches in diameter, allowing for NASA or industry to test almost any type of component or subsystem. Water flow of up to 150 liters per hour and gas flow up to 3 kilograms per hour can be provided.